Hi guys, Miss Michelson here. Today I'm going to be talking to you guys about section 9.3 in topic 9, which is all about rewriting our radical expression. So if you guys want to make sure you have your workbook out, we're on page 378. And before we hop right into these examples, I want to talk to you guys a little bit about these things called perfect squares. So before we talk about that vocab, I want us to figure out what these things are. So we're dealing with exponents right now. Everything here has an exponent of 2. And I've just changed the base of my exponent. So I have 1 squared, 2 squared, 3 squared, 4 squared. I'm just going up by 1 each time. So if you need to pull out a calculator or get out your phone, something of the sort, I have my calculator next to me that I can use if I need it. We can fill in these values here. So if I do this over here, 1 squared, remember that's the same thing as just saying 1 times 1, which is 1. And we can do the same thing for 2 squared. That's the same thing as 2 times 2. That equals 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. If we wanted to use our calculators to help us out with this, I have kind of one of the older calculators, but I could do, make sure it's on, and I can do 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. That one's always fun. 11 squared is 121. And 12 squared is 144. Now, these numbers go on forever. I could do 13, 14, 15 squared. But I'm just going to leave it alone. We've got a big list of 12 numbers for right now. Now, what we call these numbers specifically are perfect squares. So I'm going to highlight them because these numbers are going to come in handy for us in this lesson. So we've got their title here. These guys are our perfect squares. And they're perfect squares because I want to give you guys a demonstration. When we take the square root of them, we get a whole number. So say, for example, we wanted to take the square root of 25. If we didn't know that off the top of our heads, we could use our calculator. The square root of 25 is 5. Notice how it's just the opposite of the problem we did above. 5 squared is 25. The square root of that number is 5, or the base of our exponent. And that works every time. The square root of 25 is 5. The square root of 100 is 10. So these numbers up here are called perfect squares because when we try to take their square root, it turns into a perfect whole number. Now, on the other side, we can have these things called non-perfect squares, and they are not as fun. These are numbers that when we try to take the square root of them, they aren't perfect. They don't come out to a whole number. So let's say we wanted to take the square root of something like 27. If we plug that into our calculator, we would get the square root of 27. We get this decimal, and it has a bunch of numbers, and these numbers actually go on forever. So if we wanted to round this one, we could say it's around 5.2-ish. And we can do that with every other number that's not on the list. Say we wanted to take the square root of 2. That's 1.4-ish. And if we wanted to take the square root of 7, that is 2.65-ish. So these non-perfect squares are a little bit ugly because they turn into these long decimals, but our perfect squares are nice and neat. They're pretty whole numbers. So we're going to talk about today simplifying these types of problems here, not leaving them in these decimal forms. So that's all our lesson's going to be, and these perfect squares are going to help us do that. So if we take a look at example 1, part A, it asks us to compare radical 36 and 3 radical 6. Now I'm looking at that, I'm thinking, okay, they're the same numbers. I see a 6, I see a 3, I see a radical sign. Are they the same numbers or are they not the same numbers? The first thing that jumps out to me here is this radical 6, or not radical 6, this radical 36. This number 36 happens to be on my list of perfect squares, so we can go ahead and answer this one right away. What is the square root of 36? The square root of 36 equals 6. Now this one over here, this 3 radical 6, my radical 6 here isn't on my list of perfect squares. So that means that I can't simplify this as a whole number, and my best bet right now is just to turn it into a fraction. So let's go ahead and say, let's figure out what 3 radical 6 is. And I didn't mean fraction. I meant to say let's turn it into a decimal. So this 3 radical 6, if I find the value of it, is really 7.3. So we could say that 3 radical 6 is 7.3-ish. And when it says to compare, we want to pick which one is bigger. So if we wanted to write our final statement, my 3 radical 6 had a value of around 7. So that's greater than my value of radical 36. So I think this is just what we're going to answer as our first question here. Now, math people in the world have decided that leaving our answers in these decimals where we're rounding isn't as precise as we need them really to be. So instead of when we have like these non-perfect square radicals, instead of leaving them in a decimal form, we're going to teach you all how to turn this into a simplified radical. So what I'm really going to do is jump down to example A and B and down here, and then we're going to come back up to this one at the very end. But we're going to walk through how we would go ahead and simplify these radicals. So again, the reason why we're doing this is if we type radical 44 into a calculator, that gives us some long, crazy decimal. And when we have decimals, we round, and when we round in our problems, we have some sort of margin of error. So what we want to do is eliminate these long, crazy decimals and just simplify this guy right here. So when I look at this radical 44, the first thing I want to do is figure out, are there any numbers on my list of perfect squares that divide this 44 evenly? So my rule of thumb is to take this number 44 divided by 2. That's 22. My number that I choose cannot be greater than the number 22. So when I say it divides evenly, that means I need to check all these numbers and see which one divides 44 evenly. So we said half of 44 is 22. So where I'm starting on my list, my perfect square I want to start with is 16. So in my calculator, I'm going to do 44 divided by 16, and I get 2.75. That's a decimal, so it doesn't divide 44 evenly. I have to move up a level. So instead of 16, now let's check 9. If we did 44 divided by 9, that equals 4.88888. That is also a crazy decimal. 9 doesn't divide 44 evenly. So now we're going to move up to the next one. We're going to do 4. So if I did 44 divided by 4, what we can see here is that we get a whole number as our answer. So my first step is to find a perfect square factor that divides this number evenly. So once I figure those out, I'm going to break it up, 44, into its perfect square and its non-perfect square. We said 4 divided it evenly, and it turned, its answer was 11. So if we look here, 4 times 11 is 44. We didn't change the value of our problem at all. We just rewrote it in a way that suits us best. We can't forget that we have our radical sign here, though. So what we're really doing now is breaking up this 44 into 4 times 11 and taking the square root of it. Now, the properties of radical expressions, tell me that when I get to this point, this is the same thing as giving each of these radicals their own little home. So I'm splitting it up one more time into radical 4 times radical 11. So they're broken up, they've moved out, they are on their own now, there's little single guys now. Now, what we should recognize here, this number 4 is on my list of perfect squares. So if I have radical 4, I can take the square root of it. And mainly that tells me that the square root of 4 is 2. So when I take the square root of 4, if we want to do that in our calculator to check, oops, that's not the right one. The square root of 4, it gives me the value of 2. Key things to note, my radical here disappears. I'm just left with this whole number 2. Now for this radical 11, I don't have any. It's not a perfect square, so it doesn't match up with any of these numbers. And I can't simplify this anymore, so I write my final answer here as 2 radical 11. And that is the simplified version. This is how I rewrite the expression radical 44. Notice how there isn't some long, crazy repeated decimal. It's a little bit more precise and a little bit nicer to work with in our problems. So we're going to do the same process for example B, but notice how example B has this 3 out in front of it. This 3 is going to change things up a little bit. We just need to not forget about this 3. So I highlighted it. We'll see how it acts in our problem. So again, our first step, we want to break the number under the radical into a perfect square and a non-perfect square. So if I take a look at my list, I have my perfect squares highlighted up here in blue. I need to figure out which one, the biggest one, divides 27. So my rule of thumb is to divide this number by 2. 27 divided by 2 is close to 15. So let's start off with the number 16. I can take 27, divide it by 16, but it gives me this crazy decimal, so 16 doesn't work. I'm going to go ahead and check 9. 27 divided by 9 is 3. So notice 9 divides 27 evenly, and it splits it up into 2 factors, which are 9 and 3. So my first step, I identify the perfect square factors that divide my radical. Remember, these guys are still underneath the radical, so we need to give them a little home. And then this 3 is still on the outside, and I'm going to highlight this so we don't forget about him out here. Now, our properties of our radicals tell us that we're allowed to split these 2 guys up when they're underneath of the radical, like we did here. We gave them each their own little home. They decided to move out. We have radical 9, and we're multiplying that by radical 3. And we really are just multiplying by that 3 on the outside as well. So let's highlight him so we don't forget about him. Now, when we get to this point, we want to find the number here, which is our perfect square. That is my value of 9 here. We know 9 is a perfect square. It's on my list. We can take the square root of 9, and that gives us 3. So we still have the 3 on the outside. We have the 3 that came from simplifying this radical. And then we have this radical 3 down here at the end that nothing can change. So my last step, we want to simplify this expression. When we have 2 whole numbers here on the outside, we can multiply them together. 3 times 3 is 9. Radical 3 would be my final answer. So if you want to make yourselves a little note, we just have to multiply by the coefficient. So we multiplied by the coefficient. And that coefficient in this problem was my 3, coefficient. So that guy right there. Let's just put a star here. We multiplied by the coefficient. So that is what we are going to be practicing today and what our Pearson assignment is about. Let's go ahead and jump back up here to B and answer this question. The first one that I want to look at is this radical 72. We're going to do the same process that we did here so that we can simplify it. Now, 72, half of that is around like 30, I don't know what it is. Let's take a look. 72 divided by 2 is 36. So I want to start with a number here that's closest to 36. But if we notice on our list, 36 is one of those numbers. So our first step, break down our 72 into 36. And we're multiplying 36 times 2 to give us 72. So our two factors here are 36 and 2. Remember, they're still underneath of a radical, so we need to remember that guy. And there is not a number out in front, so we don't have to worry about him. At this point right here, this is where we split it up into our two different radicals. We have radical 36 gets its own home, and radical 2 gets its own home. Now, the number that's our perfect square, this 36, we can take the square root of it. Following our chart, the square root of 36 is 6. So if we write our final answer, our radical disappears. This 36, radical 36 turned into that 6, and we have to leave our radical 2 alone. We can't simplify anything about that guy. We can put a box around our answer, and that is it. Oh, our question wanted us to compare the two radicals. So if we take a look, 72, radical 72 simplified to 6 radical 2. So if we wanted to compare that to our first one, notice they are the same. They are the same. Exclamation point, and we're happy because that was kind of cool. We are going to stop there with examples 1 and 2. We're not going to do 3, 4, or 5, but I do want to give us a little bit more practice problems to work on. So I'm going to actually flip my workbook over 2 pages to be on page 380. So let me move that out of the way. I'm now on workbook page 380, and I'm looking for this heading that says, "Do you know how?" Once we get there, I'm going to do problem 7, 11, and 12. So we're ignoring the ones with these variables in it. We're just going to work through these 3 problems as extra examples and to practice this one more time. If you're feeling up for it, go ahead and try these ones on your own and see if you get the same answer as I do. So the first one, we're starting with radical 80. One thing that I did was I put a list of my perfect squares on a sticky note so that I could reference it as I'm working through these examples. So if I just can move my sticky note around, I can use it when I'm working through my homework and stuff. So we have radical 80. Our first step is to find the biggest one of these numbers that divides it perfectly. So my rule of thumb, take 80 divided by 2, that's 40. So we can't be any higher than the number 40. So that leaves us starting with this 36. So let's check 80 divided by 36. That's a decimal, so I can't use that one. So let's check 25. 80 divided by 25. That's a decimal, so I can't use that one. So let's check 16. 80 divided by 16 is 5. So that is my winner here. This is the option that I'm going to pick. That means I can split 80 up into 16 times 5. Remember, those two guys are still underneath of our radical sign. Now, my rules of my radicals tell me once I have my 2 numbers split up underneath the radical, I can go ahead and give them their own home. I have radical 16 times radical 5. And radical 16 is special because it is a perfect square. So if we know what the square root of 16 is, we can go ahead and say that that simplifies to be a 4. And radical 5 is not a perfect square, so we have to leave him as radical 5. So to answer my question, the simplified expression of radical 80 is 4 radical 5. Let's do our next one. I'm going to come up here. We're starting with radical 200. Now, my first step is to break this down into a perfect square and a non-perfect square. If I take a look at my perfect squares, I want to find the biggest number here that divides 200. So my rule of thumb is to take this number, divide it by 2. 200 divided by 2 is 100. And that number is exactly on my list. So that's the number that I'm going to choose. 100 times 2. And remember, these two guys live underneath of our radicals. And once we get to this point, we're allowed to break them up into two different ones. Radical 100 times radical 2. Now, radical 100 is our special one because it's a perfect square. So we can take radical 100, because it's a perfect square, take the square root of it, it turns into 10, and we're just left with this radical 2. It's not a perfect square, so it has to stay underneath of the radical. We can put a box around our answer, and that is our simplified expression. And the last one that we're going to do is number 12, which is 8 radical 8. Let's start up here. One thing to notice right off the bat, this time we have a number here on the outside that we need to be careful of. We're not going to use that number until the very end. So I'm going to just cover it up. I'm going to ignore it for right now. So our first step is to break up our 8. We want our largest perfect square that divides 8. So I'm looking at my list. Half of 8 is 4, and 4 makes my list. So 4 times 2 is 8. These guys have to stay underneath my radical. Once they have their own radicals, we split them up. But one thing we need to remember, I covered that 8 for too long. We still have an 8 on the outside here, and we still have an 8 on the outside here. If it helps you, this always helped me, is just putting my multiplication dot here so that I remember, oh, I'm just multiplying those numbers. Now, the special radical that we have here is this radical 4 because it is a perfect square. It's on my list, so I'm able to take the square root of it. When I do that, I have to keep my 8 on the outside times the square root of 4, which is 2, times radical 2 doesn't simplify, so I'm just going to leave that guy as radical 2. And then the last thing we need to do, we have these two like terms. 8 times 2 is 16. Radical 2 is my final answer. And that is the last example that we're going to do. If you guys have any questions, feel free to email me or your teacher. Now make sure that you know how to get to Pearson or Delta Math, wherever your assignment is, and go ahead and get started on that. If you have any more questions, reach out to your teachers. They are there to help you. I will see you guys later.